My name is Matthew Wadstein, and welcome to your first hour with UMG. This course will enable you to create a full visual feedback loop that your player will be able to see and interact with using the Unreal Motion Graphics or UMG system. This is our sample-based project, and when I run it and move our character around the screen, we can see some feedback in the top left. When we take damage or gain health, it lets us know what has happened, but then it quickly goes away. Same thing when we fire our weapon or pick up more ammo, we get some notification, but again, it's quick and it goes away. Right now, for example, we can't see our current health or ammo count unless we were to change it. Same thing when we end the level, it simply says you win. Once we have completed this course, we're going to end up with this project here. And we're going to go step by step. When we play our sample finished completed project, we now get a new menu and we can interact with it. And when we are back at our main level, you can see we now have a visual feedback on our screen. You can see health and ammo at all times in the bottom corners. If we were to lose health or gain health, you can see it immediately changing. Firing our weapon, our ammo goes down. And picking up more ammo, our ammo goes up when we interact with those objects. And at all times, we can see that visually on our screen. If we want, we could also use our pause key to bring up a pause menu we can interact with, which hides our user interface. Or if we unpause, it comes back. And when we complete our level, we finish our visual feedback loop. We get a game over screen and more items we can interact with. Now, if we go back to our base project, to start with, you'll want to download this included sample project and open it up. Once you've done that, you'll have what you see on your screen here, and we're going to go and take a brief look at it now. To start off with, the first hour UMG folder is where all of our contained items are. If you want, you can open the sources panel on the left to make it easier. The character folder contains all the items for our character, so the meshes, the animations, the blueprints. And the blueprints, if we open that folder up, are where we are going to be working at for the majority of this project. If we look inside of our character blueprint, you can see we have a few print strings. It takes our current health and prints out the value. This is where we are going to be replacing our UMG code. If we go ahead and close that up, we can look at some of the other folders. Our geometry folder has a meshes folder in it that contains the items that make up our level. Our maps folder, for now, just simply contains this map we're working in. In the future, it will contain our main menu map. And then our pickups folder simply contains a few items we've already created for you that we will be using for more UMG interaction. For example, our pickup health here, you can see it has a print string telling us we've restored some health. This is another spot where we'll be introducing some UMG to replace that with a user interface rather than a print string. Next, we're going to go ahead and take a look at the way the widgets work and the widget editor itself. A UMG widget, or Unreal Motion Graphics widget, is an object we can create inside of our editor that allows us to display something on the screen. And I say something generically because it can be pretty much whatever you want. You can think of it as your user interface for your player, their heads-up display maybe, showing life and health, or it could be a menu so you can do things or interact with things inside the world. Now, to create one, it's pretty simple. We can right-click in our content browser, go to User Interface, and click on Widget Blueprint. And it's going to create a new widget blueprint. But we're going to make sure we actually organize our project. So let's go into our first hour folder, right click, we're going to go to new folder, and I'm going to create one called widgets. So that way we can keep things organized. I'm going to go in my widgets folder, and now I'm going to right click user interface and create a new widget blueprint. Now you want to make sure you keep things named appropriately. In my case, I'm going to go with UMG underscore player HUD to indicate that this is a UMG widget and it's going to be the player's heads-up display. Now, if we double-click to open it, we'll get our UMG widget editor. So I'm going to dock it to the top of my screen, and we're going to do a quick overview of the widget editor itself. Your primary interface is going to be in the middle of your screen. It's going to be your viewport, and this is where you're going to visually see all of your widgets. Now, your widgets themselves can be found in the top left corner in your palette. Now, by default, we get a 20 to 30 or so pre-made widgets from Epic. You can see them here. For example, we have our common widgets like borders and buttons and text, up to more advanced ones like list views, and then we have different panels where we can dock things. Now, all of them are important, and they will be covered in more detail in the anatomy of a widget video. But for now, know this is where your widgets are stored. And at the bottom, you can actually find the user-created section where you'll find the widgets you may have created that you can reuse in other widgets. Now, we have our hierarchy down here. Our hierarchy contains the flow or the layout of our widget. In this case, we have our root, which is our player HUD, so it's our widget. And then our first item in here is a canvas panel. And by default, it's going to be a canvas panel. As you add items to here, you're going to see your hierarchy expand and contract based on what you're doing. And as we start adding widgets, you're going to see that happen. We have our animations and our timeline at the bottom. Now, we're not going to touch on those for now, but know that you can add and you can animate pretty much any of the animatable objects inside of a widget. So, for example, if we have an image, we could make our image move from left to right, or we could even shake the text maybe in reaction to something happening. But that's a more advanced feature and is covered separately. On the right, we have our details panel. Our details panel is like any other details panel. When we click on something, it's going to adjust to whatever we clicked on and give us the information. So like you can see here for our root object, here's our details information. And for our canvas panel, here's the specific detailed information. Going back to our viewport, you can see we actually have some information around here. We have some scale information. We have some information on what size we're looking at. And in the top right, we have a very nice interactive toolbar. Now, the toolbar is actually very important because once you start working with the interface, it allows you to quickly adjust what the interface looks like so you can test things. So like, for example, you can see whether or not it has outlines showing your actual working area, whether we're using localization is over here, whether it's going to zoom in. So like, let's say, oh, we're all the way over here and we get lost. Well, we can zoom in. We have different preset screen sizes. Maybe you want to test your user interface on a phone and on a desktop. You can easily just select those and it'll automatically adjust your preview. And then you have different options that adjust based on what widget you're previewing, and we'll cover those as we need them. Now, this is the actual editor itself, or the designer. Up here you can see it's the designer section. In addition to that, we have the graph section. This is your traditional blueprint graph. You have your basic event graph, and then you have any additional functions, macros, variables, dispatchers, and subgraphs as needed. Now, the important parts in here are going to be these three widget events that you can see here, our pre-construct, our event construct, and our tick. And we'll get into more details on that one as needed. But this is our basic blueprint layout. It's not going to be any different than any other blueprint layout if you've used blueprints before. If you haven't used blueprints before, then as we start going through our code construction and we start fleshing out our user interface, I will cover in detail all of these sections as we need them, why we might need them, and what they would be useful for. Now, with that said, this is our basic editor layout. We're going to go ahead and cover the anatomy of the widget next, and we're going to cover how we would work with widgets and how we would add them and how they work in terms of our user interface. Now that we've looked at our widget editor, so we can understand where things are inside of our editor, let's go ahead and look at widgets themselves. We're going to make this simple. We're going to start with an image widget. So in the top left in our palette, we have our image widget. This is just a widget that allows us to display a color or a texture or something like that. We can drag it from our palette right onto our viewport, or we can drop it right on top of an actual other widget to parent it to, right here, our canvas panel. So I drop it into our viewport, and now we have an image. And we can move it around. In the top right, you'll see when we move it, we get our position to change. And if we were to resize it, we get our size to change. Seems simple enough. Now, this is the very important thing to understand about the way widgets and the UMG system works in terms of the hierarchy. It has a fixed parent-child relationship. If you've ever used an XML-based layout system, like maybe in C# or Blend, you will understand this. If not, well, this is very important to follow and pick up. We have our canvas panel here, and this is our parent. You can see the common properties. We have things like behavior, accessibility, and transform. We have our image. It is a child of our canvas panel. And we can see our common properties again, accessibility, behavior, and transform. Above that, we can see our individual properties for this image. The appearance. We have things like the brush, or what you're going to see, and its color and opacity. And above that, at the top of anything where it's a child, in this case, the image is a child of our panel, we have our slot, canvas panel slot. Now, this will change based on the panel your children are actually in. In this case, our child is a child of canvas panel. So we have these settings. You can see the position, and you can see the size change. We have additional things like our anchors and alignment, but these are specific to the canvas panel. And let me show you that. So if we grab a vertical box, we drag a vertical box and we drop it into our viewport here, we are making our vertical box a child of our canvas panel. So we get, again, our common properties, and then we get our slot canvas panel properties. So we can move this wherever we want. We can position it. We can change its size. If we grab another image and drop it right into our vertical box in our viewport, or again on top of our hierarchy like this, that image now becomes a child. And if we click on it, we now see our slot is different. It's a vertical box slot because our parent is a vertical box, and we no longer have the same properties. We no longer have our size. We no longer have our position. We click on our other image. We have position, alignments, anchors. We click on this image inside of our vertical box. We no longer have those. We just have default fixed settings for padding, size, and alignment. The reason for that is our vertical box, if we go over our highlight, is a vertical box widget, which basically allows us to automatically put children in a vertical layout. So think of it like a list. So it doesn't have positioning. It doesn't have size. The children will be the size of the parent when we move it. Any additional children, we'll drag more images in, for example, will automatically be added. And I can easily show you that. We'll change our color, for example. So now we have 3 children inside of our vertical box, and their size is all determined by the parent and the settings for our slot. So in this case, maybe we want them on the middle like this, or we wanted them aligned to the right. Those are the only options we have available to us. So that's really important to understand. If you're trying to, for example, I want to put this item in a specific spot. I want it in the top left corner of my screen, 20 pixels away from the corner. You can't just put it inside of another panel that doesn't support that. It would have to be a panel that supports fixed layout, like your canvas panel. Every panel has specific settings and specific options available to their children. Those are all detailed in the documentation if you want more information. Or you can just read the information and you can play with it. And of course, as we go through this course, we're going to discuss, and I will show you the different options as we lay out our layout. With that said, that is the anatomy of a widget in terms of the parent-child relationship and how you would add them to your viewport. We're going to go ahead and get started with creating our first interface next. With the basics of the UMG editor now covered, let's take a look at our project. We're going to go ahead and run it again so we can determine what we need in our user interface. Right now, we don't really have anything, but we technically have our crosshair in the middle of the screen. When we fire, it tells us the ammo count in the top left, and if we were to pick up health, our health would go up or down. But right now, we can't actually see any of those values because nothing's being persistently displayed. So we're going to want our health and our ammo, and we're going to want to figure out why our crosshair is in the middle of the screen and fix that. So let's look at the crosshair first. Before the UMG system was created, the HUD class was created. So if we go to Character, Blueprints, we can find a file called HUD_first_UMG. If we open this up, this is where our crosshair comes from. The HUD class is going to be drawn as part of the game framework, and it's going to draw the texture for our crosshair every frame in the middle of the screen. Well, we're not going to want to use the HUD and the UMG system, so we're going to move this crosshair from the HUD to the UMG. But first, we need to disable the crosshair being drawn in the HUD. So let's go ahead and go into here. In our game mode, so GM_first_UMG, we have the HUD class. We're going to change this from the first_UMG to none or HUD. Either one works. Neither one has the crosshair. We'll close that out, and we'll hit play. Now you notice we have no crosshair. So the first problem solved. The next part is getting this all working in our UMG widget. Let's clean up our current example that we were using. So we can click on something in our viewport and delete it with the delete key. Or we could select an item in our hierarchy, our vertical box, for example, and delete it, and it'll get rid of it as well. So let's put our crosshair in here. So let's grab our image from our palette and drop it into the middle of the screen. Under Appearance in the Details panel, we have the brush. If it's not open, go ahead and expand it. And this is the image we want to show. We're going to choose our crosshair, and the crosshair is going to show up. Now, the first thing to notice in here is this says the image size is 16 by 16. But remember, we have a canvas panel as our parent, so it's actually determining the size. We can choose size to content, and now it's going to fit it to whatever the image says its size is. It's a little bit too small, so let's go with something like 48 by 48. Now we have a much bigger crosshair, and we will just eyeball it right around there. That looks good. Now we need text for our health and ammo. So let's grab a text, drop it down here in the bottom left. We'll grab another text and drop it in the bottom right. And now we have a spot for our health and ammo to go. We're going to lay it out so it looks like what we want it, so we can make it look better. So we'll do health, 100. And then over here under the other text box, we're going to go ammo, 100. So now our text and our ammo is going to be displayed on our screen. Now we can go in here and we can move these around a little bit, for example, so it looks better in the bottom left. We can do the same thing with our ammo, so it fits more in the bottom right. Now, one thing you might notice is this little green box that's around there. The green box is actually representing the size of this widget, and our text is going outside of it. Well, just like this, when we have size to content, we don't have size to content turned on over here under our parent panel. So if we do that, now you notice the box will change. If we do the same thing with our ammo, you'll notice the box size changes. Now these are a little small. Let's make them a little bit bigger. Let's go with something like 36 under font. So you can go under appearance, font, and change the font size to 36. But you'll notice we have a problem. Now part of it looks like it's outside of this little outline. This outline is representing your viewport, or what's going to be on the screen when it's this setting. And if we were to run this, we're going to find that these words are now outside of the screen. So let's fix that. We'll use the green box to determine where we want it in the bottom right, like that. We'll go back over here to health. We'll change this one to 36 as well. You'll notice it changed a little bit, and we'll do that. And now we've got that set up basically like we're going to want it to look. So we have our crosshair, we have our health in the bottom and our ammo in the bottom, and this looks good, and visually we're done with the way we want to look. But we don't have anything actually working data-wise. So we're going to go ahead and look at our events in order to get our data from the character onto the screen. Now that we have the visual layout of our player's HUD created, we need to go ahead and hook up the data component of it, or the code behind. We can do that using our blueprint event graph. So in the top right, we have our graph section. And if we open it up, we get a standard blueprint graph. We get a couple events that are already created for us. And then we can create our own if we want to do anything custom. Now we have our event construct. This is what happens once the widget is constructed or created. We're not going to use this for our project. We have our pre-construct. It's like the construct, except it does it during design time. So for example, if we wanted to change this text right now, we could use the pre-construct event, and it would change the text right now during design time. We wouldn't have to run it to see the changes. And that's useful when you're doing things like nested widgets or more advanced features, and you want the update in real time. We're not going to use that during our project either. And the last one is our event tick. So our tick is a traditional tick. It's basically every time the game updates or a frame is updated, the tick fires. Usually you don't want to use these. They're very intensive because you're doing something every time. Let's say, for example, it's your player's health you're updating on the tick. Well, if your player's health only changes every 2 or 3 seconds because they're not getting hit very often, it seems silly to continually update it. Now, if it's something like a timer that maybe updates every tick, it's a very precise timer, maybe in a racing game where it's down to the 100th of the millisecond, the event tick is useful. In our case, we're not going to use the event tick, so we'll go ahead and get rid of that as well. What we're going to do is use a custom event. We're going to use kind of like a data-driven way to update our interface. If the health changes on our player, we'll update the interface. If the ammo changes, we'll update the interface. We don't need to constantly check for the ammo every frame. We're just going to update it when the player gets new ammo. Makes it simple. So we'll right-click and we'll add a custom event. So if you right-click and type custom event, you'll get add custom event. And we'll name this something really simple. Update health. Every time we want the health, which is going to be this variable right here, to update, we'll call update health, and we'll set it to a new health value. Now we're going to keep our user interface very simple. We're not going to do anything fancy with layouts and multiple widgets and nodes. We're just going to use the simple text that says health a number and ammo a number. So we're going to need to take in a value in order to update our display. So to do that, on our custom event, we can take in an input. So down here under details, we can add a new parameter, and we can call it whatever we want. I'm going to call this the new value, because this is the new value that we're going to display on our screen. Now, by default, it could be Boolean, it could be byte, it'll be whatever you've used last. We're going to want to take in a float, for example. Now, you can take in something else. You could take in a text. You could take in whatever you want, and you could display whatever you want. In our example, we're going to take in a float because we're going to manipulate it a little bit before we display it. So that way our player has more options later on. For example, if we took in a float of 70 for the health, we can maybe hook it up to a progress bar and show a nice little life bar. We're giving ourselves more options later. Now, in order to update the text, we're going to need to set that value. So if we go back to our designer, we go back to our health, for example, and we look, we have a text property called health 100 that we're going to want to set. But the problem is we have no way of getting access to it inside of our blueprint. It needs to be a variable. Right here we can see our image, but where's our text? Well, by default, text isn't automatically a variable. If we go to the top right under details, you'll see is variable. You check that and hit compile. We go back to our graph. Now we have a variable called text 003. Well, that's not very helpful. Let's rename it. Let's rename this to text health. Now we have a variable called text health. And let's go to ammo, and we'll do the same thing. We'll call this one text ammo. Make sure we check is variable. We'll compile it. And now we have two variables we can play with, text ammo and text health. Each one of these is a reference or a way of finding this exact value, this health and ammo. And we're going to want to change the text property. So we grab our text health and we get it. Now we know our text health right here. We have this actual widget right here in this little node right here. And we're going to type set text. Under widget, we have set text. And it tells us it directly sets the text. We click on it, and now anything we type in here will be the text you see on your screen. Great, super simple. We'll use the execute wire hookup right here. I'm going to drag this over here so we have room to mess with it. And now if we were to put this on our screen, we're going to have nothing. We want this to be in here. So if we drag it and drop it, well then we get a nice little handy conversion node. And now we'll convert whatever we sent over to here. Problem is, this is the number 100. This is text. We want it to say health:100. So we're going to use some helper nodes. It's pretty simple. We have the append nodes. So if we do append, we find string append. This will allow us to convert multiple things into one thing. Let me show you. So we'll type in health:, space, and then we'll drag our new value here into here. And what it's going to do is it's going to output health:, space, and then the value from here. We take this and plug it into our text. We have all these funky little conversion nodes going on. It's a little bit longer than we'd like, but all we have to do now is say, hey, user interface, update the health with this new value, and all of this code will say, okay, we're going to update it. We're going to say health:, whatever value, and put it on the screen. Really simple. The nice thing is we get a cheat for the next one. We'll do custom event. We'll type update ammo. We're going to clean this up here. We'll grab all this. We will copy it. Control C or right click and you can copy. Control V to paste and paste it onto the screen. Hook it up. And now we have another node set up to do the ammo. All we have to do is update a few things. So instead of saying health here, we'll change it to ammo. We don't have our input. So we'll do the same thing here. We'll call this one new value and we'll hook it up here. And we'll move this over a little bit, make it prettier. So now it's going to take in ammo and write out ammo. And then here where it says text health, if we right click on it, we can change it to a different value, or we can delete it and we can grab text ammo and hook it up here, or we can delete that and we can do the same thing we did, grab text ammo, get it, and hook it up here. So now we have two events. One updates the ammo, one updates the health, and that's it. Right now, we've got our front end set up, so that way we have something else show on the screen. We have our back end set up. Whenever we call update health or update ammo, the front end is going to change, and we're ready to go. Obviously, we have nothing on the screen, and we have no values hooked up, but we have our user interface ready to go for the next step, which is going to be putting our HUD onto the screen. Now that we have our player HUD UMG widget created, we have the visual component here, and we have the code component created. we need to actually get this onto our screen. But before we do that, we need to figure out where we're going to put it. Where's the best place for this? Now, this one's actually pretty simple. This is our player's HUD. It should go on the player. Why? Well, it's the information of the player. If the player was, for example, to be destroyed, this is information we may not want displayed anymore. It seems kind of weird to show the player's health if the player is getting destroyed and completely regenerated, for example. However, maybe you want it displayed at all times. So there are other places to put it. You have places such as, well, the HUD class. Even though we're not using it, maybe we want the HUD class to handle creating it and storing references. Maybe the game state. That's something that is controlled inside of the game. Maybe the player controller. Maybe this is something specific to the player controller that will be persistent throughout the entire thing, like maybe a menu. In our case, we're going to put this inside of our character, our player. So let's go into blueprints. Let's go into our character, first hour UMG, and we're going to put this inside of here somewhere. When our player is created, well, we want the user interface to be created. So this is pretty simple. We right click and type in begin play, or if you have an existing character, find your begin play event, and we're going to hook it up to the begin play. Now to create a widget, it's pretty simple. We'll right click, we'll type create widget, and we find under user interface, create widget. Now this is going to ask us for which widget to create, who owns it, and then gives us a reference to it. In this case, we have a single player game. We're not really concerned about who owns it. We're just concerned about what we want to show. So I'm going to select my UMG player HUD. We're going to compile and save, and then we're going to hit play. And nothing happens. Just because you create a widget doesn't mean the widget's actually displayed on the screen. Once we create it, we get a reference to that widget, and then now we need to actually put it on the screen. So if we drag off of our return value, which is the widget we created, and type in add, we have two real options under user interface viewport. Add to player screen and add to viewport. 90% of the time, you're going to want to use add to viewport. Add to player screen is specific for split screen stuff. If you're not doing split screen or multiplayer on the same screen, you want add to viewport. We'll click add to viewport. We'll clean this up. We'll hit compile again, and we'll hit play. And now we have an actual interface again. We can move our character around. We have a nice big cursor in the middle of the screen. We have health on the bottom left, and we have ammo on the bottom right. Looks like we're done. Except, well, obviously when we move around and pick up stuff, we still have the text in the top left. And we don't really have 100 ammo or 100 health. We don't actually have any of those things right now because we haven't set anything up properly. We need to hook up our default values and use those actual events that we created earlier inside of our player HUD or UMG widget. So let's go ahead and look at that. So the first thing we're going to want to realize is we need a way to talk to this widget later on. So we're going to actually want to create a reference to this widget so we can talk to it later. So to do that, let's go ahead and move this over. We're going to unhook these. We're going to drag off our return value, and we're going to promote it to a variable. We're going to go down here to our variable list and name this something like player UI ref or player UI reference. And now anytime we want to talk to this widget, we can just use our player UI reference. We can go ahead and hook this back up. We're going to test to make sure everything looks the same, except now we have a reference to our player UI. Now, at this point, we want to tell our player UI to update its health and ammo values. We have some health here, 100, and we have some ammo, 20, but our UI has no idea about it. Since we're going to do this every single time it starts, or maybe the player is going to die, we're going to make a custom event just so we can continually call this as needed. Technically, we're going to make this into a function to make it cleaner. So if we go to functions, new function, we can call this one update default UI. And when we run this, we're simply going to talk to our player UI. So I'm going to drag this out and get it and tell it to, well, update health and update ammo. Update health, grab our UI reference, update ammo, and we're pretty simple. We just need to fill in our values and it's going to take care of everything else automatically. Pretty simple. We'll hook up our first wire here. We'll move this out of the way temporarily, and we need our value, health value. Oh, here's our health. Drag it in, drop it, and there's our health. Simple enough. We need our ammo. Let's hook up our wire here. Grab our ammo, drag it and drop it. Well, it's not compatible. So this is our first issue we're going to run into. When we created our interface, we didn't really have any documentation. We were kind of just screwing around. But now we have an integer and we need it to be a float. Well, do we need it to be a float? A float is a number that has a decimal point in it. We don't have partial ammo, we have full ammo. So we need to fix something here. Let's go back to our HUD and look at that. Now our health maybe can be a partial number, so we're going to leave that as a float. But our ammo needs to be a full number. It needs to be an integer. So let's fix that. So we're going to take in a integer instead of a float, and it's going to break stuff. We're going to hit compile, and now we get errors. Well, we can't convert a integer to a float to a string like this, so we'll delete it, and we'll just drag and drop it. Go back into here. You'll notice this now says it's got a warning. If we right-click, we can refresh it, or we can recompile and save. It'll change it over to an integer now. Drag our integer in. There we go. Now we're updating our health with our health and our ammo with our ammo. If we hit play, you'll notice, well, we have health 100 and ammo 100. Well, what happened? We just told it to update. Why didn't it update? Well, yeah, we created this. We didn't actually tell anything to run. Let's grab our update default UI, drop it in here, connect it up. Now after we've created our widget and added it to our screen, we're going to tell it to update with the default values. We'll hit play, and now you notice it says ammo 20 in the bottom. It says health 100.0. That's something we can worry about later. Again, it's a visual thing. We'll cover that later. But we now actually have it going to the proper values. And I can show you that. Let's say the player starts with 150 health. And, I don't know, let's go with 24 ammo. We hit play, 150 health, 24 ammo. So now we've hooked up our interface. We have an actual interface on the screen, which we can see here. We have events hooked up that we can call and update that interface. And then we have our player, when it starts up, creating that interface and updating it with actual values that are real, not just fake. We actually have real valuable information here. We can't update it in real time yet, because when we collect things, those things aren't telling anything to update, but we have the basics set up. At this point in our project, we have our user interface updating with the default data whenever we begin play. Now the problem is, whenever data changes, our ammo or our health count, for example, the user interface doesn't change. We're going to look at the primary methods of updating that. In this case, we have two events already created, our update health and update ammo. Whenever we call it with new values, it talks to the user interface here, talks to those events, and updates the text values. However, there is another way by property binding. Property binding is basically the ability to change any of these properties that can be bound. For example, in our text, the text can be changed, or color and opacity, for example. We have these binding options. And it's going to update it automatically for us. So let's go ahead and do bind, create binding when we're next to text, and we get this nice little function. Now I can show you it working. We're going to type in ammo none, for example. We're going to compile and save this. We're going to go back into our player's blueprint, and we're going to unhook update default UI. We don't want to update the UI ourselves. We want the HUD here to handle it itself. We hit play, and now you notice it's going to show ammo none in the bottom right corner. The problem with this is bindings are run basically on tick every frame. And I can show you that. If we do print string, this is going to print out hello every time this is ran. So when we hit play, we're going to be spammed with hello. The disadvantage of this is if something doesn't change often, for example, player health or ammo, it's definitely not going to change every frame. This is going to look for an update every frame, and it's going to cost resources to do that. So it's not really very beneficial to bind like this. It's easy, but it's resource intensive, and we really don't want to do that. I can actually show you why it would be nice. If we get the player character, we're going to go ahead and convert him. We're going to cast to the first person character right here, the first hour UMG. We're going to convert this to a pure cast by right-clicking, and we're going to get the ammo count. So what this does is it says, hey, give me the ammo count from my character that's currently in the level, and we're going to return that value. We're going to hook this back up, and now when we hit play, you're going to go ahead and fire, and you'll notice in the bottom right, my numbers change. And if we were to pick up more ammo, it's going to change automatically. The disadvantage again, though, if we print string, and we plug in, let's say, our ammo count, and then do this, and hit play, you'll notice it is showing our ammo count. If we fire, and it's going to continue updating. Every single tick right now, update, 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 update. We're not doing anything, but it's updating. So it's a little bit resource intensive and really shouldn't be used unless you need something that should update every tick. Like, let's say, a timer or a countdown or a clock, something that should be accurate to the display that you might want to bind. We're going to go ahead and get rid of our function. We're going to just click on it and delete it. We'll recompile and we'll get an error. It says, hey, you had a binding, now you don't. What happened? So let's just go ahead and go back to our designer for our text binding. It now says none, which actually doesn't mean none. It means, hey, what happened to the function you had there? Remove the binding and go ahead and compile and save back out. Now, if we hit play, we're going to go back to our defaults, go back into our character, hook back up our default update, and then test. And now we should be back to where we were when we started this project. 150 health and 24 ammo. It represents our health and ammo count, our default values. We're going to go with the pushing method, which we already are using. Whenever we update our default UI, even though we only do it once, we are pushing the data to our UI. So let's do that wherever we need to in here. So if we look for wherever we have print strings inside of our character, it usually corresponds to when something happened. In this case, when our ammo is adjusted, we set the new value, and then we print out the new value. Same thing with the health. If we simply get rid of that information, we're going to go ahead and drag our player UI reference in. We're going to update the ammo in this case and hook it up. And then we can go ahead and move our little ammo count here and hook it up. And now whenever the ammo is updated after this is called, it's going to update it on the user interface. Same thing here for our health. We'll grab the player UI reference and get it. We'll update the health from our player UI, hook it up. We'll go ahead and hook up our new health value here. And now whenever update health is called, whenever this any damage event is fired, we're going to update the health with our user interface. Now there is two other spots we need to update. If we were to look over here, whenever we fire something, we update the ammo and then we print out the results. So let's do the same thing we did before. You can actually just copy paste. So we'll copy this node and we'll copy this node. Control C to copy. Control V to paste. We'll hook it up and move it over a little bit. Adjust this. And now we have our new ammo count. I want to be cheesy and grab just these three things. Right click copy. Go back over here to the end. Delete this entire section. Paste it. And now whenever we were printing out, we're now going to go ahead and actually update the UI. We hit play to test. Here's our default values. We walk over our damage and our health goes down every time. We walk over our health going up, our health goes up. We fire some ammo. You'll notice our ammo count goes down. And we pick up some ammo and you'll notice our ammo count goes up. We still have stuff in the top left corner that shows up because that's the item itself mentioning that. We also have the issue here when we win, well, nothing happens. And then there's the issue of our UI itself not really respecting layout. You'll notice, for example, when I do this, our ammo on the bottom right gets really weird. And then at certain points, our health disappears. And our cursor in the middle of the screen, well, it just plain disappears at one point. And that's because we're not really using the proper layout system for our user interface. At this point in our project, our user interface, when we run and test it, doesn't really adhere to very good user interface standards. It doesn't really stick to our corners like we might expect when we resize, and elements like our crosshair completely disappear. So we're going to go ahead and fix that. If we go back into our HUD and we look at the way our HUD is set up, in previous videos I mentioned that our parents control the way our children are laid out, and I mentioned we have anchoring, which is our little star or flower pattern up here. Let's go ahead and start with each element and put them in the proper positions. So here is our crosshair in the middle. And you'll notice our anchor is the top left. So that means as our user interface changes, so down here, for example, we can see this little set of arrows that we can adjust our crosshair. We can adjust our interface for testing purposes. You'll notice at different times we start losing things. If we adjust it properly from the bottom right, we're going to anchor to the top left and it's going to end up disappearing. So let's actually change our anchor to the middle. So using a canvas panel, we have the anchoring system. We can click on anchors. You have all your options here. You can notice you can hold shift to update the alignments and control to update positions. So those are shortcuts to updating these values here. I personally prefer to type in these things manually, so I'll show you that method as well. If we click on the center icon here, you'll notice our flower goes to the middle. We are now anchored to the middle. That means as our UI adjusts, we're going to attempt to keep this in the middle of the screen. So if we were to play now and we adjust, you will notice our crosshair now stays in the middle. That's a good first start. Second, you'll notice this doesn't really match up properly in terms of where this says the middle, our anchor point, and our image says the middle. That's due to sizing and alignment. So alignment is set in a 0 to 1 fashion. 0 is nothing, or 0%. 1 is everything, or 100%. The upper left is 0, 0. The bottom right is 1, 1. So to center along the top and the middle, you'd have 0.5 and 0.5. So if we change our alignment here to 0.5 and 0.5, it's now going to center it in the middle. Now the issue we're seeing here where this is kind of not looking right is, here's our positions. We're now anchored to the middle. So how far away from the middle do we want our position to be now? Well, we want it nothing. We want to be dead in the middle. We want no offset from the middle anchor. Now you'll notice our anchor is set to the middle, and our image is now aligned into the middle. So our crosshair is going to be perfectly centered. Let's look at our health next. Here's our health. This one should be pretty simple. It's our bottom left. So anchor to the bottom left. Now whenever the screen changes size, our health is going to try to stick to the bottom left. Now how far away from the bottom left is this? Well, this is weird. 40 and negative 93. This is where alignment comes in again. How do we want it? How far left and right do we want our alignment to be in terms of the X? Well, we want our alignment to be our left side here. So 0. How far down do we want it to be? 0 or 1? Well, the bottom left is 1. So let's do Y of 1 for our anchoring. Now it's going to anchor it to this bottom left corner. So this corner here is going to link to this corner here. Now we could type in positions to get it exactly where we want it. We could go with, for example, 40 and negative 40. So 40 over and 40 up. And now it's going to stick 40 pixels away from that corner, no matter what we do with sizing our screen. And if we were to go ahead and play this again and check it out, you'll notice when I resize, it sticks to that bottom left corner as best as it can, 40 away every time. Good. Now we need to fix the bottom right, because that's not working very well. Should be pretty much the same method, except now it's the bottom right we want to anchor to. So anchor to the bottom right. Set our alignment. Our alignment should be the bottom right. So our X this time is going to be 0 or 1. It's going to be 1. We want the right side. And our Y is going to be 0 or 1. 0 or 1. We want 1, the bottom. Now we're going to anchor this corner to this corner. But of course, again, our position is funky. So let's go negative 40 again and negative 40. And now it's going to stick to 40 away from that bottom right. We hit play and we check it out. Now when we resize, look at that. We have our UI respecting whatever size we're using as best as possible. So someone could be playing on a 640 by 480 square screen, an ultra wide screen. We have our UI respecting as best as possible. Now, one issue you're going to run into here, and this is more of like advanced features or more just making things look better now that we have anchoring done, is making your UI respectable. So in the bottom right, we have our ammo 24. And you'll notice again, it's anchored here to here for this bottom corner. If I fire enough ammo to get it down below 24, watch what happens. The entire thing moves to the right. And when we pick up, the entire thing moves to the left. So our UI itself is shifting because it's not really fixed in position because of a few things. One, we don't really have a mono-spaced font. We don't have a fixed space font. So our font itself can change size left to right. Second of all, our value here where we have 100, this will change left to right based on if it says 100, 3 characters, 99, 2 characters, or 9, 1 character. And since we're anchored to the right, it's going to shift from left to right. So you can see it here. And if I start deleting things, 10, and then, for example, 1, it's going to keep shifting. Now, we can layer or overlay widgets inside of widgets, and they can each have their own respective alignment. So that's something we can do and we're going to look at here. So we're going to change this to a fixed size. We want this entire thing to be a fixed size. And we can actually change that here instead of being size to content. We could change it to a fixed size. So for example, maybe 200 by 50. That way it encompasses the entire thing. 200 is not going to be enough. Let's go with 250. So we'll go with something like that. Change our ammo back to 100. Let's go with 260. There we go. So now it's going to be a fixed size. And when these things change, for example, you'll notice it now goes ammo 10, ammo 1. So this is a good first start. We get it play. You'll notice it's 24. We'll go down. The ammo itself is never going to change. The word ammo, it's just going to increase or decrease in the value for the ammo itself that we're picking up. That's because we are no longer resizing our box. We have it a fixed size and it's anchoring. Now, if that's not something you want, you could do things such as, again, layering panels. So we're not going to do this. We're going to keep this, but here's an example. Here's a horizontal box. So here's a box that lays things out left to right. We could put our text in here on the left side and our text right next to it. So now you have a horizontal box with 2 items in it. Your left, for example, could contain the words ammo, and the right could contain a count of 100. And now our box itself has individual settings in it. Again, our parent controls the layout of the children for how the items inside fit. So in here, it's set to auto. It's set to expand as much as possible. This one's set to auto, expand as much as possible. We could adjust that. Let's go ahead and change this box to the same settings we had here, 260 by 50. So we'll go 260 by 50. And let's go ahead and change this ammo here to the right. And we'll go ahead and change it to the center. And we'll tell it to fill. And this one, we'll change it to the top and the bottom center, but left align fill. So now, if we were to update these values inside of here, let's say we have 100 here, and we change it to 99, it's going to go to the right. We change it to 9, it's going to go to the right. And this ammo, because we're saying, hey, go to the left and stay to the left no matter what, it's going to stay to the left. And if we want to change our box itself, maybe something like this, change this value to something like 910. You can notice we can lay out everything in a nice, easy fashion. Something like maybe that right there. And then no matter what happens, when our ammo value itself changes, it's going to stick to the right, and our word ammo is going to stick to the left. And then, of course, we could just anchor this to the bottom right. So that's an example of using parents and childs and layouts to organize the way your display is going to look. Now that we have our basic UI created, so when we play, we can actually see things on the screen, we can collect things, or fire off our ammo, and our counts will go up or down. We want it to be a little bit more presentation worthy. Traditionally, you're going to have an interactive element when you start up your project, be it a level selection or configuration. So let's go ahead and create a basic main menu. Let's close out our blueprint, and let's go ahead and make a new level. Let's go into our maps folder. We want a blank level, so we can right click and do level, or we can go to file, new level, and select empty level, and this will give us a new blank level. Let's save it while we're here, so we'll hit save all, and then we need to go to file, save current. Let's go to maps, let's go to map underscore main menu is what we're going to call it, and save it. Now we have a main menu that we can work in, a map that we can load up before our actual project itself. We're going to need a widget because we need something on the screen. So we'll go to our widgets folder, right click, user interface, widget blueprint. We'll name this one UMG main menu because it's our main menu, and we'll open it up. Now that we have it open, what are we going to put in it? We're going to make it simple. We'll have a background and we'll have 2 buttons. We'll have a new game button and we'll have a quit button. So if we go ahead and drag in a button and drag in a button, and then we could drag in an image, and there we go. We're good to go. Well, let's do it a little more proper. Let's give ourselves an actual layout and use panels to make it look and function well on any display. I'm going to delete my image, but still stick with my buttons. Now our buttons are going to be in the middle of the screen, and we're going to want them centered. And we're going to want them one on top of the other. So if we look at our panels, we have a vertical box. And a vertical box will lay out our children vertically. So we'll click on our first button, we'll right click on it, wrap it with a vertical box, and that's going to go ahead and put that button into a vertical box. Now we could take the other button, drag it onto the vertical box, and now we have 2 buttons in our vertical box. Now they're a little squished, so let's take our vertical box and tell it to size to content, so that way our vertical box will fit those buttons in exactly like we want it. Our buttons are really plain right now, so let's put some text on them. So we'll find our text, drag that onto our button, or drag it onto the button itself in the UI, and you can see it updates. And now we have 2 buttons with text. We're good so far. Let's update our text to show it correctly. So we'll do new game. And then our second text block is going to say quit game. And there we go. Now we already know how we want to lay this out. We want it in the center, and we've done that before. So let's grab our vertical box, and let's anchor it to the middle. And let's set our alignment to the middle, so 0.5, 0.5. And let's set our position X and Y, or our offset, since we're using a middle anchor, to 0. And now we have everything centered in the middle. Still a little stiff. It still looks a little squished. So now we can adjust the settings for the items inside of our vertical box. So inside of there, we have our 2 buttons, and you can see we have things like padding and alignment. Let's center them, and let's give it some padding. Now, padding has the ability to pad it all around or individually. Let's give it something like 10 for padding. You'll notice we have an outline here for our vertical box. We have our button in the middle of it, and then we have 10 unit padding all the way around the button. We could do the same with our other one. We'll do 10. And now it's a little better. We have actual space. We have a little bit of better looking to it. Let's go ahead and clean up our font a little bit. We'll go to here. We're going to change this from Roboto Bold to Roboto Light. We'll do the same thing with the other one. We'll go to the font, change it to Roboto Light. Now it looks a little better. We'll save and compile. We're good to go. Now we want an image in the background. I don't really have an image to use here, but if you slap an image into the background, we want it to take up the entire screen, so we'll do anchors. In this case, you have the bottom right option here, which is basically going to fill it all the way. These ones will fill along the sides, the middle, or the top, middle, and bottom, or the entire thing. You'll notice it now splits it apart, so it now takes over the entire thing. Of course, we do have our options here, which is why it doesn't look right. We don't have, for example, our offset set to 0, so that way it has no offset, top left. We don't have our offset right set to 0, so it goes there. And now we have an image taking up the entire screen. And if we needed to resize this, you'll notice it's going to stay the entire screen. So that's good. However, it's overriding everything. We kind of have an issue here. Well, we have a couple different options. We can use the Z order. So that's basically how far away it is drawn away from us to towards us. Or we could put it in its own panel that's behind other things. In this case, we're just simply going to use the Z order. So if we collapse this vertical box and we look, we have our canvas panel, which is the panel holding everything, and 2 children, a vertical box and an image. And if we look over here in the canvas panel, we have a Z order option. And like I said, it orders the way it's rendered, or farther away to closer. So if we set our background image here to a lower number, like -1000, it's going to go behind everything that is a higher number. In this case, our vertical box, which has our buttons in it, has a Z order of 0. So it's going to be drawn ahead of it. Let's make our image look a little bit better. Now, if you had a traditional picture, you could put it in here. We don't really have anything. I mean, we could do a big UE4 logo. There we go. We have a UE4 logo as our background. But traditionally, use something a little better looking. Our vertical box itself is a little funky where it's at. It also doesn't really have a background. Doesn't really look right. Now, the cool thing about that is you could put like a border back there or something else. But we're going to leave it like this. This is going to be our main menu. We have an image in the background using Z order. We have our buttons ready to go to be wired up to be used. And we have our canvas panel saying, hey, everything goes on our screen and will fit appropriately when we resize. Something you can do over here is rename things. So for example, this could be our main menu panel. This could be our button new game. This will be our button quit game. And then back here we have our background image. You also have the ability to lock and hide things. So for example, if I lock the background image, I cannot accidentally select it and move it. I can only select things that are unlocked. Or if it's taking up too much space or we need to get to something else, we can hide it temporarily using the editor visibility. Once we actually load this up, it will still show. This is just for the editor. Now that the visual component of our main menu is done, let's work on the code element. When we hit play for our main menu map, we're going to end up with 2 problems. One, our player's HUD is displayed, even though for some reason we don't have a player and it shouldn't be. And 2, our main menu HUD is not displayed. So let's make our main menu show up because that's kind of the point of this. We're going to create our main menu using the system we did before, creating the widget and adding it to our viewport inside of our level blueprint. Now, if we go to Blueprints, Open Level Blueprint, we're going to open up the Blueprint graph. Traditionally, you don't use the level blueprint for much, but because this is a sample project and it's a very small item we're creating, this is fine because it's more of a one-off event just to get it on the screen. On our begin play, let's do create widget, and let's select our existing widget, so our UMG main menu. Let's go and drag off our return value and add it to the viewport. And once this is done and we hit play, we should have our main menu on the screen. Now we still have our player HUD for some reason, so we need to fix that. Now our player's HUD is on the screen because our player is in the level. If we hit play, we look over here, you'll actually see that our character is in this level. But why is that? Well, the character itself is a default pawn, and the default pawn is controlled by the maps and modes and the game mode. If we go to edit, project settings, and we go to maps and modes, you'll find your default game mode. In here, the game mode first hour UMG. And if we expand the advanced menu, you'll see under default pawn, we have our first hour UMG. So for any map that's created, it's going to go ahead and automatically spawn in this character. But that's not what we want. So we need to create our own game mode that'll override the existing one. So if we go to our first hour UMG folder, I'm going to create a new folder called Blueprints. And we're going to create a new game mode in there. Right click in the folder, go to Blueprint class, and choose game mode base. We're going to name this GM_main menu, which is a game mode for our main menu, and open it up. Once we have it open under class defaults, we have the different defaults for our game mode, and one of them is going to be our default pawn class. Change that to done. We don't want any pawns spawning at all. Once you've done that, you can save it and compile it and close it, and we're done with our game mode for now. Go back to the map for our main menu and open up your world settings. If you don't have them open, go to Window, World Settings, and then go down to our Game Mode Override section. Change this to our Game Mode main menu and hit Save. Now when we hit play, we get what we expected. We no longer have a character loaded up, and we have just our main menu. Of course, it doesn't do anything since we haven't hooked up anything, so we should probably do that now. Let's go ahead and stop that, and let's open back up our UMG for our main menu. Now, if you have your level blueprint open, you can go ahead and close it for now. We don't need it. Let's just clean up a little clutter. In our graph view, we have our events. We don't need any of our predetermined events. We're going to make custom events for when we click on the button. But how do we do that? Well, you notice we have as variables over here our buttons, even though we didn't actually tell them to be. Well, the engine knows if you made a button, you probably want to use it, or else why would you create a button? And as part of the button, we have our click event. So if we go back to our graph and click on any of our buttons, in our details panel, we have our events. These are events hooked up to these buttons when stuff happens. So on clicked, on pressed, released, hovered, and unhovered. In our case, we want on clicked. So click on new game for the variable, and on clicked will create a new event for whenever the button new game is clicked, and do the same thing for button quit game. We'll click on that, on clicked, and now we have two events for when these buttons are pressed. We're going to wire up the quit first because it's super simple. Drag out of the execute, type in quit game, and that's it. Whenever this button is pressed, the quit game node will be called and the game quits. We can test it by hitting play, clicking quit game, and it quits. We're good to go there. The next thing is when we hit new game. So when we hit new game, we want another level or map to open up. And that one's pretty simple too. We'll drag off, we'll type open level, and this will open up a new level. In this case, we want to open up the other map. So if we go back into our content browser maps, we have our map first hour UMG. I'm going to right click and rename it so that way my name pops up as selectable. Control C to copy it. Go back into our blueprint, Control V to paste it. Now I know it's going to load up the correct map. We'll hit play to test it again, hit new game, and there we go. We have a problem where my cursor is now on the screen, but my map did load up and we can use it. We also have a second issue. If we hit play and we don't click on these buttons, but we click on the background, now my mouse cursor is gone. That is all due to the input mode. There are 3 input modes in the engine. If we right click and type in input mode, we'll find input mode UI only, game only, and game and UI. By default, the default input mode is input mode game only, which means all the input from the mouse and controllers and peripherals and the keyboard go through the game itself. So usually your player controller or any other devices set to accept input, and it absorbs that input, which means your game viewport is going to take it and not your UI. But that's not what we want. We want our UI to take the input. So let's go ahead and fix that. So if we go to our widget itself in here for our main menu, when we leave here, we want our input mode set to game only. But when we load up this map, we want it to be set to UI only. So where do we load up this widget? Well, it's our level blueprint. So go to Blueprints, open level blueprint, and we have our existing code here. So we create our widget, put it on the screen, and now we want to change our input mode. So let's go ahead and set input mode to UI only. We don't have a player, so we don't need it to be set to game. And we'll go ahead and compile and save. Now this is going to want a player controller, or it's not going to work. So let's go ahead and drag off, and we can type get player controller, or you could type get player controller and drag it on. Either one works. But now that it knows which player controller, which is the one that our player is going to be using when the project is running, it's going to set the input mode to UI only. So if we hit play again and we click in the background, well, I lose my cursor, but you'll notice my buttons are kind of highlighting. Well, that's because my UI has input, but my cursor is not being displayed. And that one's pretty simple. Set show mouse cursor. However, it's not going to show up. If we uncheck this, it'll show up. It's because it needs a player controller input. So if we actually drag off of our player controller and do set show mouse cursor, now it's going to show up. We'll go ahead and hook this up, and we want our mouse cursor to show, so we'll click that. Now we'll compile and save and hit play. We have our mouse cursor like before, but when I click on the background, it doesn't disappear, and it works like we expected. We hit new game, we go into here, however my cursor still shows up. And you can't tell, but I can't actually move my player anymore. Well, remember where I said we wanted to set it to UI mode when we're using the UI? Well, now we want to set it back to game mode when we're going to be using the game. So you don't want to put it after the open level, because once open level fires, nothing else can really be guaranteed to run. You're opening a new level. So let's set it before that. So the same thing as before. Let's copy this stuff out, and we'll paste it into our main menu and hook it up. However, we don't want the UI only, so we'll delete that, and we'll do set game only. So input mode game only. We'll hook that one up like that, and we'll go ahead and put this little guy right in between. Now we don't want the mouse cursor, so we'll uncheck that, and we'll compile and save and hit play. Mouse works properly on our main screen. New game works. I can move my character. We have no cursor. Everything works like we expected. So that's something important to note. You have 3 input modes. The UI one sends everything to our UI UMG elements. The game one sends everything through the game loop itself, primarily the player controller. And game and UI, which we haven't touched on yet, sends things to both the UI and the game, which is important when you need your actual game to take input like from your keyboard, but your UI to take things from like the mouse. In order to cover those, we're going to create an advanced menu. We're going to create a pause menu in the game so we can bring all of these things together and start wrapping things up. We are at the point where we have a main menu. So if we hit play, we can interact with our main menu. We can quit or hit new game. And we're presented with our project, which now has a working UI that adjusts itself as we use ammo or health. However, we still have some messages on the top left screen. We have a win event, but no actual end screen. And we have no real way to restart our game if we get stuck or quit. So let's look at creating a pause menu, so something we can access inside of the project while it's actually running. Let's go back to our actual player map. So let's close down everything that's loaded up. We'll go to maps and then the first hour map. Now we need a player pause event. So we need something where when the player pushes a key, the pause menu will come up. To start off with, we're going to need to go to Edit, Project Settings. We're going to need to go to Input, and then we're going to need a new action mapping for pause. So these mappings are when we push something on our keyboard or any other input event, something will happen. So we'll go to Action Mappings, Add. Our new action mapping will now be called Pause. Since we can't use the escape button during playing editor, I'm going to use the P key. So scroll down till we find the P for pause key. And that's it. Now we have a new event called pause that we can call. The problem now is, where do we put our pause menu? Our player HUD is inside of our player because it's uniquely tied to elements inside of our player, like their ammo and health. The main menu is tied to the level blueprint in the main menu because it doesn't really connect to anything else. But our pause menu isn't technically part of the level, but it isn't part of the player, we could create a new blueprint for it, but we need the input to go through somewhere. Now, all of your input when you're using the game will go through the player's controller, the player controller. So let's actually use the player controller to implement our pause event. Now we need a new player controller. So let's go into blueprints. We're going to right click, go to blueprint class, and create a player controller. We'll call this one PC your first hour. And now we have a player controller that we can put code in and run our pause event. Now by default, it's not going to actually be hooked up. So let's go into our game mode for our first hour game mode right here, GM first hour UMG. And let's set our player controller class from player controller to PC underscore your first hour. We'll save this. Now if we run this and we look over here on the right, we can actually find that inside of here. PC your first hour. So now we know we're working with the correct player controller. Go back to blueprints, open up the player controller, and let's implement our event. So we're just going to use code. So let's go to the event graph. We don't need anything already by default. And we'll do pause. And we'll type in pause, and you'll end up with the input action event pause. And that's what we created. Now when this is pressed, we want something to happen. Well, this is pretty simple. We want to create our widget and then add it to our screen. But we don't have a widget created. Well, this one's actually pretty simple. Our main menu widget will work fine for our example here. It has the ability to restart by hitting new game and the ability to quit. So let's just do our main menu since we know it works. So we'll go ahead and do that. We'll add it to our viewport. And now we have a pause menu that we can pull up. So if we go ahead and hit play, we can move our character around. We can hit P, and now we have a menu on the screen. However, as you notice when we're running around, well, the game's not paused and we can run around. That seems really silly. Now there's a couple things we can do here. We could set our input mode to UI only. So let's try that. Get player controller, because we're going to set the UI mode. So set UI mode to UI only, like that. And then we're going to go ahead and show the mouse cursor, because we know we need that. If we don't, we can't actually click on anything. So set show mouse cursor. We'll hook that up. We'll hit play. We'll compile and save. Now when we run it, our character can aim and look. We hit P to pause. Now we have our interface. The arrow keys no longer work. The mouse no longer works to look. And all of the input is going to the user interface. So that's great. The game's not actually paused because you can see it running in the background. But we have a good, nice pause menu working. We could hit new game and it'll restart. Or we could go ahead and hit quit game and it'll quit out. But we want to actually pause this because we don't want our character to die, for example, in the middle of the project. And we want to stop everything from processing. That one's pretty simple. There is a pause game node, set game paused. And if we enable that and we do paused, then the game itself is going to pause. So we'll hit this, we'll hit P, you'll notice nothing's spinning, and we're good to go. Now we have an issue here. How do we get out of the pause menu? What if we just accidentally pushed it? Well, the P button doesn't work, and we have no return or anything. Now we could set up our user interface to have a close button, or we could make it where our game and our UI both accept input. Going back here to the input mode UI only, if we unpause this, so we'll unhook the set game pause, and we hit play, even though the game's no longer paused, the P key no longer unpauses or pauses this menu here, because input is only going to the UI. And our action inputs, so this pause button here, only works when it's in the game input. So let's change this to set input mode game and UI. We'll go ahead and hook these back up for the player controller like this, show cursor, and we'll run this. Now we can move around. We can hit the P key. We can interact with our menu. However, you'll notice we can still fire, and we can unpause this if needed. Now you notice it's not really unpausing. If you kind of notice that when we were running this, the pause menu here is getting darker and darker. Well, what's happening is every single time we hit pause, we are creating a new widget and adding it to the viewport. We're not actually checking to see if we have an existing widget. We're not actually checking to see if we're paused. We're not doing any of that stuff. So in the next video, we're going to look at more advanced features for the interface, such as how do we run these events when things are paused? And how do we make sure we don't duplicate our user interface elements if we already have one on the screen? The current problem we're running into is we're recreating our widget every single time we hit the pause button. And we need to stop that. Now there's two ways of doing this. You can check to see if that widget exists, which is the way we're going to do. Or maybe you just set a Boolean somewhere that says, hey, is pause menu showed or is pause menu not showed? Or, I mean, you could even check to see if we're using this pause thing if is game paused. The easiest way is to actually just check for validity. So whenever we push this pause button, we're going to check and see if this menu is created. In order to do that, we need a reference to it. So we're going to drag off of this and promote it to a variable. We're going to call this one the pause UI reference. We'll unhook these wires and hook this up in between like that. And then we'll go ahead and do everything we had before, except we now have a reference. Now to check and see if a reference is valid, well, we use the isValid node. We'll get our pause UI reference. We'll type isValid, and we'll end up with two nodes. They both work the same. They just are different functionally. We're going to use the top one just because it makes things easier, and hook that one in and go like this. Now this is technically backwards. We're going to say, hey, pause. Do we already have a UI up? If so, create a new one. So we're actually going to want to switch that. So we'll go like this, drag this down, unhook it from here, and hook it up here. So now, no, we don't have a valid pause UI reference. So let's go ahead and create a new one, create a reference, and add to the viewport. We're good. The next one is, well, do we have one already? Well, if we do have one already, let's go ahead and hide the one that's on the screen. So let's grab this one right here, our get pause UI reference, and we're going to remove it from the parent. So this will remove it from wherever it's at currently. So if it's got an existing parent, it removes it from it. If the parent is the viewport, which it is in this case, it'll remove it from there. Now, once it's removed, it still exists. Remember, we can create and add. So just because we removed it doesn't mean we uncreated it. So the next thing we're going to want to do is set this right here to nothing. So if we grab our pause UI reference and we set it to nothing, that means our UI reference is now referring to nothing, and this is going to invalidate itself and be removed later on. We can hook this up here like this, and now we have some code which will basically go, hey, do we have the UI on the screen? If so, remove it. Do we not have the UI on the screen? Then create it. And then let's go ahead and set up our input mode so that way we can actually work with the UI. We're going to hook our pause node back up here, and we're going to test it. We'll hit play. Okay, everything's looking good. We'll hit pause. Everything's paused. We'll hit the P key, and nothing works. Well, the reason for that is when it's paused, input's paused as well. However, if we go back to our input node here, there's a nice little checkbox that says execute when paused. We'll check that. We'll compile and save and try it again. Our character can move. We'll pause. We have our interactive UI. We'll hit the P key again, and you'll notice we can now have our UI disappear. We'll hit P, and now every time we hit P, our user interface toggles. We're only keeping one active. You did notice a small issue. We never really unpaused the game, so that's a small problem. So right here, we don't want to go back to pausing the game or showing the mouse cursor. We kind of want to do the opposite. So let's move this down. This is only going to be exclusive if we need to create it. We want to do the opposite. So this should be pretty simple. Grab our player controller. Let's move this up a little bit so we have a little more room. Put our player controller here. What is our default input mode? Well, our default input mode is game only. So let's set it back to game only like that. And what is our cursor status? Well, we want it to be unvisible. And what's our game pause status? We want it to be unpaused. So let's grab those nodes. We'll paste them and move them over. Hook our player controller back up. No longer show the mouse cursor. No longer pause the game. We'll compile and save, and we'll hit play. We can move around. We can P to pause. Everything's paused. We have nothing going on. We can interact with our buttons. We can hit the P key to unpause. And look, everything's working again. And we could just spam our P key as much as we want to continually pause and unpause. And that is our basics of our pause menu working and how you would work with an existing UI element. This part here is important in regards to working with an existing element because the creation and destruction of UI elements takes up resources. Since we don't plan on our player using the pause menu often, it's okay to go ahead and create it and destroy it. But what if it's a UI element that gets toggled often? Let's say you're using like an inventory or you have a heads-up display that can be visible or invisible. Well, then you may simply want to remove it from the parent, but not get rid of the reference. Let it sit there, just hidden basically. And then you can bring it back later if you want by simply adding it back to the viewport. So you don't set it to nothing, you would just simply add it back to the viewport. Now, our next issue is going to be the fact that when we hit pause, our player UI is still displayed. We want a nice clean pause screen. So let's see about toggling that. Since we already have things set up, let's easily toggle things on and off. So we'll go ahead and close down this right here. And we're going to want it where when we pause, we toggle the HUD elements off. Now, in order to do that, we actually need to somehow talk to the player UI reference again and tell it to hide those UI elements. Well, in our player, we have a reference to the player UI. So that's simple enough. Let's create a new event where we can toggle our interface on and off. So let's grab our player UI reference, and let's go ahead and get the text ammo, for example, and let's set its visibility to hidden. And let's do the same thing. Player UI, we will get the health text right here, and we will set its visibility to hidden. And then our last thing is going to be the crosshair. Well, unfortunately, our crosshair is not actually visible right now, so that's not going to work. Also, it seems kind of silly to do this, turning individual things on and off when we could just turn the entire thing on and off. Why don't we do that? Kind of like how we mentioned before in terms of removing and adding to the viewport. So here's our player UI reference. Let's remove it from the parent whenever this event's called, or let's add to the viewport if we want to add it back in. So now we need some way of calling this. So for example, we can do a custom event. We could do toggle HUD on. We could do a custom event called toggle HUD off. And whenever we call these, we're going to either toggle them on or off. We should probably put them in the correct order here like this. So toggling on and toggling off. So now if we got a hold of our player and we called toggle HUD off, it'll remove our HUD from the parent. If we called toggle HUD on, it'll add to the viewport. Since we're always keeping a reference to that UI after we've created it, it's going to keep it basically hidden from the player. Let's go back to our player controller right here. And now let's toggle it on and off. So in this case, we are removing our pause menu. So we want to toggle it on. So let's go ahead and get the player character. Let's cast it to my first hour character because he's the one who's controlling this event. So we'll go ahead and make it pure again so that way we don't have to hook it up. And then we're going to drag over here. There we go. And we're going to toggle HUD on. So whenever we remove the pause menu, we put the HUD on. Let's copy this code here, paste it, and move it over, and we will toggle HUD off. So whenever we put the pause menu on the screen, we're toggling our HUD off. Compile, save, and play. Now we should have our HUD. We'll hit pause. You notice our HUD has now disappeared. We will unpause, and our HUD comes back. Now we have a nice clean pause menu by toggling the HUD. And we toggle the HUD by simply removing from the parent and adding to the viewport that player UI that we created initially in our character. Because when you create the widget, it still stays in memory even if it's not visible. And that is important to remember. That is also why we had to set the reference to our pause menu to nothing so that way it would remove it from memory later on. At this point in time, we have almost everything finished. We have a working pause menu and everything's updating. We just have a few more things to finish up. We have those nasty little text messages at the top left. And we still can't finish. We can't finish our feedback loop. We can't start, play, and end because we have no end. So we're going to work on that next. Now that we've gotten the majority of our project completed, we need to finish it up by wrapping up the actual gameplay loop. You'll notice when we collect ammo, it still tells us we're collecting ammo. And when we actually go to our endpoint, it tells us you win, but nothing happens. So let's finish that up by finishing up our UI. So the first thing is we need some sort of a UI. We need something to show up when they end the game. So let's make this really simple, and we're going to duplicate our main menu by right-clicking and selecting duplicate and name it UMG Game Over Screen. Since this is going to contain the majority of the things we want, we duplicate it and we're off to a great start. Now our Game Over screen is going to display Game Over. So let's actually slap some text in here, which we can't really see. So let's fix that. Our background's a little annoying for what we want to do here. So let's change our background image. Let's actually not use the logo. So we're going to clear that out. and let's make it something a little more subtle. We're going to make it our solid color. We're going to change the alpha to 0.2, and now we have a nice gray transparent background in the background. With that done, now we can actually see our text. So let's change this to game over. And let's go ahead and make it bigger, center it, and do everything we've worked with before. So we have our text. Let's make it bigger. We have our font under appearance. Change that to 112. It's not centered, so let's work on our anchoring. So anchor it to the top middle. Well, it's not aligned very well, so let's put it over 0.5 on the X. So remember that will center it to here. 0 for the Y, which means it'll center it to this spot right here. However, if you notice, it's only going to center this spot right here, this actual box, and not the text, because the text is overflowing. Well, let's size it to content, so now it's the entire box. Still not perfect, because we have an offset, so let's do 0 on the X, so it's centered left to right. And let's do something like 115 on the Y, so it's down a little bit. Now we have a game over. Let's change the color to something like a green to indicate a nice success. And we're done with that basic part. Now we have our buttons. We want 3 buttons this time instead of 2. We want the main menu, restart game, and quit game. Well, restart game and new game in this case are the exact same functionality. So let's just rechange our new game into restart game. We'll go ahead and rename this to button restart game. Let's go ahead and change the text as well to say restart game instead of new game. And we should be good there. Now we need a new button. We can drag and drop, and we can recreate all of our settings, or we can just duplicate. So we'll right click and we'll duplicate, and now we have a new button down here called Restart Game 1. Now this one's going to be our main menu, so let's rename it to main menu. Let's rename our text to main menu, and let's put it in the correct spot. Now how do we get it in the correct spot when it's at the bottom? We're using a vertical panel, which means all of the children are vertically aligned, so it has things to help us do that. We can drag and drop because this panel orders everything in the order of its children. Or if we click on each individual child, you notice we have these little helper arrows. So we can click there and there, however we want, and it'll go ahead and reorder the children for us automatically. So now we have restart game, main menu, and quit game. We're good here. Let's go ahead and go into our graph. Our buttons are already hooked up for restart and quit, and they'll do exactly what we want. Now we just need to hook up our main menu. So main menu, click on clicked. Let's go ahead and drag it up so it's with the rest of our buttons that we want to interact with. It's going to do the exact same thing as when we restart, except it's going to go ahead and go to a different level. It's going to go to the main menu map. So let's delete that. Main menu. And now all of our code is correct. Our main menu button will go to the main menu. Restart will restart the map we're on, and quit will quit. We're good with the layout. Now we need to actually get it on the screen. So when our game over event is triggered, it should display it somehow. So we need to figure out where the game over event is, and then we need to handle where we're going to handle it. Now we know when the game over event triggers, something's printed on the screen. We also know we need to clean up the other stuff that's printed. We can easily find it by going to Window, find the blueprints, and type in print string. And this will find all the nodes with print string. In this case, we have our ammo that we want to fix. So I'm going to double click on print string, remove the print string node, and hook back up the destroy actor node that was after it. And we've now fixed that issue. I'm going to grab the print string here in my level end. We'll close this since we don't need it anymore. And now when we win, we're no longer going to print string, but we're going to create our user interface. Now at this point, we can create our user interface and set it up on the screen inside of our level ending blueprint. However, maybe we want to do something else. Maybe we want a score to be saved, or a game to be saved, or something online to be done. We don't really want to tie that to this specific blueprint that's unique and can be reused. However, we have something unique to this map, which is our game mode. So we're going to go ahead and put our handle game over code in our game mode. So let's find our game mode. So under character blueprints, we have our GM underscore first hour UMG. So this is our game mode for our map that we're currently loaded. Open the editor if it's not open, and let's create a new custom event. We'll call this handle game over. This is really simple. We'll call this and we'll do stuff. Now that we have this set up, let's make sure we implement it so we don't forget it. So whenever this happens here, when our overlap begins for our level end, let's get our game mode. We need our specific game mode for our first hour. So let's cast it to that. Now we have our specific one. We're not going to make it pure this time. We're just going to hook it up. And we're going to say, hey, let's handle the game over. So we're going to hook that up to our output right here. And now whenever this event is called, handle game over will start. Let's double click on that node, and it's going to take us back to our game mode for handling game over, and we'll hook it up. Hopefully at this point, this will be the third time we're doing this, and you already know what to do, and you're ahead of me. We're going to create a widget, because that's what we want to show on the screen, and hook it up. It's going to be our game over screen widget. We're going to add that widget to the viewport so it's on the screen. And then we're going to want to take away control from the player because, well, they don't need to do anything right now but click on buttons. So get the player controller, set the input mode to UI only. We only want UI only because we don't need them pushing like the pause key or the quit key or any of that stuff. We're going to give them an interface to click on. And then we're going to want to give them an actual cursor to click with. So set show mouse cursor. We'll hook this one up here. And the final thing after we've enabled show mouse cursor is probably to pause the game. So let's do pause game with the set game pause node. So that way nothing else happens in the background. This should be the basics of what we're looking for. Let's go ahead and play and find out. Our character can fire, things go down. Our character can lose health and gain health. Our character can now walk up to the end. The game pauses. You can see the little particle effects paused. We have buttons we can click on. We have a game over screen, but we kind of have this ugly health and ammo thing still on the screen. Hopefully you know exactly what we're going to do. We did it before. Since we did it before, why don't we just copy the code? We don't need the blueprint for the level ending open anymore because we know it works, so we'll close that. Now, where did we handle hiding and unhiding things before? Well, we did it when we paused. So let's find our pause ability. So we're going to go to blueprints, player controller your first hour, and this is where we did it. We toggled the HUD off right here. So go ahead and copy these nodes. So if you want to know how to add or remove things when you're selecting, Control will allow you to individually select single nodes. Shift will allow you to add nodes. So for example, if I control click these three, I will select these three. Right click copy. Go back to our game mode. We're going to paste it here at the end. So control V. We're going to hook it up. And at this point in time, when we run this, we should now be able to go to our end. Our end screen should show. Our HUD is gone. We have a nice, clean ending. And we can go ahead and restart the level. We could go back to the main menu, or we could quit the game. And we have our actual finished loop working properly using the UMG system for all of our interface events. Now that you've gone ahead and followed along with this course and finished our project, you may be wondering what to work on next. Well, during this course, we've learned the basics of the UMG widget system. We've learned things like layout of the UMG system. We've learned that we have some included widgets that we can use to create a user interface. Things like our graph, which allows us to interact with that user interface and call custom events. We have created a basic gameplay loop. So if we go and open up our main menu here, for example, and we hit play, we have a screen that we can interact with. We can send the player right into a new level or a new area that we want them to work in. We have interface on the screen. We have our targeting reticle or crosshair with a health and ammo display that is updated in real time as we interact with things. We can finish our loop by ending what we've been doing and then restarting, quitting, or going back to the main menu. With all that said and done, there is a lot more you can still learn. So if we open up the documentation on the documentation site for Unreal Engine, and we go to the Engine Features UMG UI Designer, you're going to find a lot of documentations that you can refer to work on next. Some of the basic stuff is you have the widget type reference. So this covers the included widgets that come with the engine. But more importantly, you have things like how-tos and a designer guide. The how-tos are great because we get some advanced options and advanced courses and learning material, like maybe a drag and drop UI or more advanced information like scaling. We saw the anchoring setup, but there's also scaling for higher and lower DPI devices. You have extra stuff like the user guide, which includes things like safe zones for different types of devices, different types of fonts, clipping effects, even using the UMG system inside the editor itself to create your own widgets for handling editor functions. There's a lot more things you can do, so go ahead and explore the documentation, and I hope you enjoyed this course.